Come on. Hello guys, welcome to the very first workshop of the semester. My name is Yash Karwal. I'm the Calpine 1 of Hyperloop's president. I see you guys all here. It's almost a full room. That's kind of good. Let's get started today. My first question before we get started though, how many people here are experienced in 3D modeling? It's advanced. Alright, it's pretty cool. Okay. How many of you guys are engineers who are new Solidworks for today? Alright. Cool. Okay. Alright. So, what is CAD? Right? So CAD stands for computer aided design. It's how we model things on a computer to showcase, to simulate designs that we have using there are many subsets of 3D modeling or CAD. There's 3D modeling, we have 3D design, and we also use for architecture and for 3D planning. So that's like layouting of your buildings and everything like that. There's many more as well. Right. So why do we CAD? So our computers can simulate a lot of different conditions than what we can do with just our hands. We can use CAD to actually simulate flow fields, like airflow or fluid flow on an object and see how it could react in real life, but not the in real life aspect. 3D modeling can also help with 3D printing, for FDM and SLA are two types of 3D printing that we use. FDM being our normal 3D printing that we actually use plastic that we feed through nozzle. SLA being resin. If you guys have seen resin, the liquid UV light shine through to harden. We also use CAD for 2D printing, so like laser cutting and CNC machining and PCB fabrication, and to communicate our designs to other manufacturing people or drawings. Today, using 360 and SolidWorks to 3D model these cases here, these stands right here, which are for our Hyperloop soldering workshop and circuit construction workshop. Right, so our PCB will be on this board right here. So there's some other 3D modeling softwares as well. There's Autodesk Inventor, SolidWorks, Onshape, CAD, and Blender. They're all used by many people. Autodesk Inventor and SolidWorks is used most by industries. All right. So some important topics that we're going to discuss today is going to be 3D modeling with manufacturing constraints or tolerances, dimensions, to get your part right. So when you 3D print it out, it's going to fit all together into one. And also how to visualize your product or an object in the computer, as well as introduction to modeling and some 3D and drawing intervention. So here's some examples of CAD. A render of our Hyperloop pod of 2 years ago. Here our little image render as well. An assembly file over here. We also have an RC card that we made with a LiPo battery. And this right here is part of a Banshee UAV. We actually built this in real life as well. See, it's in our room. And this right here, actually part of my friend. She's a graphic designer who designed all the graphics for this. I designed the actual components themselves. Together, we basically did a mock-up of what her packaging design class needed, like show and render. Comparable to regular PCB interface. Well, all right. So some tolerances. How to use a caliper? The caliper right here. I have one of mine here. As you can see, like this. So this is very widely used to actually measure small precise measurements. So you have your outside. If you want to measure any thicknesses, you're going to go on the outside, the gap. You use this side to measure the inside of the step. So if I see how far something is, how tall it is from, let's say, some other reference point, you can use this side. These usually have, this is a digital CAD one for like this, which has different units. Also an analog one, which just uses a dial and goes around. You can do a lot of cool dimensioning and then using that to actually model your parts. But to keep in mind that a lot of materials that you 3D print, plastics like to shrink a lot. So you got to keep in mind how much they shrink and compensate for that in your 3D model. So about 2 millimeters or so, you want to give a tolerance of putting plastic to plastic. If you do, let's say, a clearance hole, right? Something has to go into another thing, but it has to make sure it doesn't actually get stuck inside. Let's say the hole 2 millimeters bigger, 2 millimeters bigger than that hole, at the thing that goes into the hole, right? Yeah, so tolerances. If you want to put the two pieces together, like I said, use a test print to figure out exactly what your machine's tolerances are for 3D printing wise, and then to adapt to that, let's use some testing. Using a test fit strip too. Yeah. Any plastic, no matter what plastic it is, just PLA, but ABS, G, HIPS, all shrink because plastics want to come together. So yeah. If you're doing, let's say, plastic on a piece of metal, this metal is already like a proper constraint. Metal will not shrink, so you got to make sure you put it to that as well. But yeah, so tolerances are important for any kind of thing though. Laser cutting, if you design, they also have their own variances of dimensions. So you can't do exact measurements. You have to do some variability. And if some objects, let's say, if you want a really precise object you want to manufacture, it's a really small tolerance or it's a really small variable of the dimension, it costs a lot more to do. So with 3D printing, since that large variability is large, it's going to be a lot cheaper to manufacture. All right. For 3D printing, you want to make sure that when you design something, you want to make sure that there's like least amount of supports as possible. The supports tend to fail a lot, as you can see right here. These are all support material. And if any of those fail, the entire print will just. You want to make sure you have a flat base. So if I were this person right here who was printing these glasses out, I would try to use the frame of the actual glasses, the bed. It goes from top, bottom to top. Like anything, like gravity will take hold. It'll feel less with these glasses than if we're on the bottom and it was like this, right? And you see some resin printing over here as well. That's the way of printing. So I would, since these glasses are mostly flat, I would use a flat base to print it instead of using the side. If these glasses were curved as well, then maybe I'd probably go like this as well. I'd make a nice layer to make sure that is stuck. Some more SLA. So again, that's the UV light that is the resin. But resin printing is a little different because that resin can also get stuck inside. You gotta make sure you have a hole, model a hole in the actual print, because when it hardens, it can cause an explosion and crack actually your part because of that extra resin inside of it. Yeah, the caliper is used for accuracy and positioning and tolerances. You can always print like you're gonna print a large assembly, right? With a lot of links. You might want to make a small, so just the link itself to make sure that their link will, actually work for printing a large part, because that'll be a lot of waste of material as well and a lot of time. So test prints are always good to have. There's been a lot of times where I didn't do test prints and a lot of months of work has gone down the drain because of it. There are two types of manufacturing that you see in the world: additive and subtractive. Okay, the additive you build on top with the material. So additive is like 3D printing. You only use the material that you need. You're adding to your part. Subtractive, you take material out. So subtractive is you've done it for a longer time, It's been used, let's say CNCing is one subtractive method as well, drilling. So it does use more material, or you have more waste material. So additive is mostly cheaper, but it is a little slower because of 3D printing at least. To say CNCing a machine, right? But that will look like, depending on how you, let's say you model, right? There are multiple ways of modeling one piece. For instance, what we'll be doing today with this, you could think of this as an additive method. First, taking the small base, putting the pillars up, the center up, and the top. We're going to do the subtractive way. You get the whole rectangular prism first. You take out parts that you don't want. Remodeling wise, both will produce the same exact piece. Sometimes you'll have more or less functions to do it with. So more or less processing you gotta do. Alright, so file types. There are file types that you guys should be familiar with. I'd say the most important being STEP, STL, and OBJ. These three you'll see commonly used in your entire 3D printing, 3D modeling career. So that file being, say, if you have a file, one program to another, you want to still build a model or build off of it, use a STEP file. So what this will do, it will create a solid body that you can still edit the basis of. You won't have the actual functions themselves because they're from different functions, right, or different applications. But you can still edit the piece. It's pretty much editable. Like STL and OBJ, these will create a mesh. STL does a lot of triangular meshing. OBJ also is similar. OBJ is used more for visual effects, or Blender or something like that, or more like animation-wise. STL is used mostly for manufacturing stuff. Also, another one called 3MF, it's less used. It's also these file types. The G code is, once you put your model to a STL or OBJ, you can put this into what's called a slicing program. So a slicing program slices up, we'll talk about later, but it's like breaks your part into slices, literal slices for 3D printer print. So that's the code. It's like millions of lines of code to generate the 3D printer print. All right. There's different orientations as well you guys should get familiar with. The first one being isometric. Think of it like looking at it at an angle, right? Normal, if you look at an object, you'll see three faces usually: front face, side face, and top face. That you have right here. This is really good for when you draw out or you want to think about how to approach modeling something. You want to first go to, let's say, what thing you want to use first. It has the most information that you can use to create that very first object, right? For this object, you probably want to create probably the top face a little bit first, or doing the top of the front. Sketches are, well, most of the software that we'll be using today, it's sketch-based. Blender is not sketch-based, but Solidworks, 360, Onshape, all those other ones are all sketch-based, where you'll create a sketch onto a plane. So a 2D sketch of what you want, and you'll bring that sketch out into 3D. Yeah. You first start off with any perspective you want, or any piece from the origin, and then from there you would want to go out. There's open profile and closed profiles. Open being there's let's say one line, an open polygon. A closed profile is a closed polygon. You have a thickness and everything else is defined. All right, those are constraints as well. We'll go over. Constraints are very useful in creating certain relationships with say points, arcs, like say a tangent arc or something, to make sure it stays a constant radius or it touches the correct spot. Yeah. You can see on Fusion right here, an unconstrained sketch will just give you all blue lines. You can drag any of these around. It will change your entire sketch. This is a constrained sketch, usually fully dimensioned. It will have the proper constraints on it so that these lines will not go out. If you were to click and drag on any of these lines, they will not move, they'll be fixed. so you can't mess up your SketchUp. Here's our basic UI for Fusion 360. However, these functions are going to be for almost any 3D modeling software out there. Once you know one 3D modeling software, you know basically all of them. Right? You have your extrude, cut, loft, sweep, revolve, pull, fillet, taper, and shell. Very commonly used for almost everything you do. No matter what you're going to make, the most complex thing or the most simplest thing, you'll be using these functions the most. Right? They're everywhere on every single software. Extrude, like I said, extrudes in a linear way. When we cut, it's just extrude, but cutting into rather than extruding. Loft will have two separate faces. It'll kind of like map a circle and a square into one another. You'll see that later on. Sweep and revolve. Sweep will follow a path you create. Say you create a rectangle, right? And you want to follow a path. You sweep it around like a brush. So look at a 3D object that way. A revolve is just a revolve, sort of like a water ball right here. You want to say cut into half and revolve it around. So if it's a hole, a fillet is just a bevel. Taper is a bevel, but like a full cut on the sides. And what shell does, it creates the outer shell of your object, inner side being completely hollow. You need a hollow object. Shell is the way to go. All right, drawings. So drawings are also very important to help communicate what your part is to, let's say, manufacturers. If one of, let's say, make you 3D model something, you want to give it to an injection molding company. You need to know exactly what dimensions to use or how to create your part. That's where drawings come into play. You can create drawings. It's like a blueprint of your part. You'll have your front, side, top faces as well. Basically, putting any dimensions that are important to creating your part, you put it in there. So this is like basically, you can follow this along. You can make that part there basically showcasing. It can be really detailed, but no redundancy. All right, so manufacturing-wise, you want to do is you want to export your files into STL. So click on the save as mesh, create STL binary with millimeters. This will help save the file into the proper file settings for your 3D printing. You put in your slicer. So this right here is a slicer called Cura. And you can see it's a little different than what you saw as 3D modeling. You have settings for your printers to like cut into pieces in each layer. Can't really tell in here, but each layer is like a sketch you could think of that you're going to make and shoot up. All right. So, good thing ahead. Half an hour's been done. We're going to start 3D modeling, learn how to 3D model. So, those who want to do Solidworks can stay in here. Those who want to do Fusion will wait. How many people can use Fusion right now? Okay. How many Solidworks users?
How long is the download?
It'll take a while. It'll take a while.
If you don't have Solidworks downloaded right now, you can always use the virtual lab because that's what I'm going to be using to showcase the Solidworks.
Oh, is it a website or
Yeah, so if you type in CTP virtual lab, you can use the Solidworks app to use the virtual lab. It's going to be a bit laggy.
But yeah. All right. Equal split, it seems like. So, those who want to join Fusion, come with me into the other room. We'll set up over there and teach some Fusion. Those who are to say Solidworks, Borick here will be helping you guys learn how to model Solidworks.
Join us.
I change my screen sharing to Solidworks.
You can just drag your you can change screen options and then you can drag it over everything to split.
Oh, sorry. Say that one time. Or you
Oh, actually, screen share it and I'll change my computer.
do they want to see the fusion or the
They're only seeing SolidWorks. Yeah, I'm not.
yeah? It, Wait, are you gonna take? Is Doctor use Matthew and then SolidWorks? Yeah, what's up? So type in this link.
No. So type in CPP virtual lab. I thought you knew.
Virtual.
Yeah. So virtual software lab.
Oh.
No. Sorry, the first one. Oh, okay. Yeah, you're right.
Oh, so you're gonna.
Yeah. Okay. Okay, so there's a lot of people for SolidWorks. Huh? Oh, yeah, it's not. Wait, how many people are over there? Okay, so who doesn't have SolidWorks on their laptop? Oh, okay. So just go to search up CPP Virtual Software Lab, and then you can click the first link. It says Virtual Software Lab. Okay? And then if you scroll down, you can click Enter Engineering Lab 02, and I believe that's where it is. Let me check. Yeah, so in Engineering Labs 02, there's going to be SolidWorks on there. So once you click Enter, it is going to start loading up your virtual environment, and once that's loaded up, you could actually get onto SolidWorks from there. So I will wait till everyone is on there, and then we can get started. Yeah. What was that? Yeah, because you're using your CPP login to use the virtual lab. Oh. You have a laptop for him to use? Yeah. Virtual software lab. What? Even if you go into the virtual software lab, can you try to go into the virtual software lab?
I already used my login. Yes, you are not an engineering major. Yeah, because the virtual software, but I would use it. Yeah, so we use Solidworks. I'm not this strong. Oh yeah, wait, does anyone have key card access? Alright, so has everyone gotten into the virtual software one? For anyone who doesn't have the download, you guys know that. Well, everyone else who raised their hands, they didn't have Solidworks free out. Were you guys able to get into the virtual software lab?
Oh, I'm not the
That's fine. Yeah, so like from there, you would then type in like Solidworks and like Solidworks will show up. So I will check to everyone install it.
No, that's the thing, I can't get into.
Could you open a new tab? So open like the private tab.
I mean, I'm not pastor, it's industry representative, but you want me to sit up there or something? I don't like sitting. That's where you was all over, so I made a reference. Wait, you said no. Oh my god, probably. How much do you know? Because I did the class, but you had an internship.
I don't know how you guys budget for all this stuff. Other stuff is like, oh, it's
So I know those things. Yeah. I use log a lot, but I don't think
which was annoying.
you did a lot of drawings.
Yeah.
If you do like GD&T where you're trying to do all these, that giant like formatting list that you have to choose.
But I like copied it from like Solidworks.
Okay. Yeah, I work a little with that. So probably a little less. Yeah, I mean, sure, I guess. You have to go through a comb through a texture though, right?
Did you log in? Because he wants to. Because he has the lowest one to say this.
Yeah. That's okay. Well, because one of my friends. I'm pretty sure. Well, I mean, I know you have to print it more, but I think.
Are you doing like you're going to have to
That's wild. What do you do? You like you're white, you're even like a one of my friends. Have you ever played on the garden? They have a very long and you don't understand. I don't know, that reminds me when you said you dreamed into it. Kind of like that's crazy. Oh, okay. This Sunday,
Oh, yeah. I don't know what this is like nine. Yeah. No, this is all Wait, you know what you're solved, right?
Yeah.
Okay. So you'll be a helper until customers.
Oh, this is supposed to be.
Yeah.
I got you.
Everyone is looking at
Okay. So just to introduce myself again, hi, I'm Borick, just friend of the club, helping out, and I am not a SolidWorks expert. I think I know enough that I can teach like the pure basics, some tricks, and like to basically get you like started. And at the very end, I'll probably have them post a link in the Discord of like what I use that helps me learn SolidWorks also. If you ever like forget anything from today. Alright. So, alright. Once you open SolidWorks, you should get a screen that looks like this. And then, so there's three parts to just 3D modeling, right? There's making your part, making the assembly, which is putting a bunch of parts together, or making a drawing, which is essentially like saying how manufacturer would make the part itself. But we're just be focusing on making a part today. We're gonna just go through like the pure basics. So if you click part, you could leave this as so you're going to get this pop-up and it's going to talk about like the dimensions you want to use. So because we're in the US, we're going to stick with like inch, pound, and second. I'm going to have you guys switch it later on just because like I want to show you where that function is to switch between units. So you just keep it like that to this standard and then click OK. Sorry, there you go. Then small. All right, give me 1 second. I'm not sure why it's
so small. All right, there you go. Then minimize this. So what we're going to be making today is going to be this. So in our workshop series from the last couple of semesters, generally the previous president, Chris, he makes a bunch of these cases, and then he generally, in further workshops after this, he has like a PCB that actually goes onto this, and he like screws it in for the workshops that he hosts. So we're going to be making something like this today. So there's no guarantee that we're probably going to be using this in future workshops, but I will be showing you how to use like SolidWorks tools to make something like this. Okay. So does everyone have SolidWorks open? Yes? Anyone has problems? Okay, so just to go over the different parts of SolidWorks right now. So up here in the tabs, you're gonna see like a bunch of different settings. Like, so for example, right here is your features, where this is where you will actually make the 3D modifications. So if I have like a sketch of a circle, this is where I'm going to use it to make it into a 3D physical shape, or I'm going to use it to actually cut something, or I'm going to use it to revolve something. So essentially, your features tab is where you're going to make your 3D features. And then here's the sketch tab, where before you make the 3D features, you're going to be making sketches first. So on here, you're going to see a lot of different tools. So you're going to see sketch, which lets you go into a mode where you could start actually putting lines, circles, or any kind of shapes. You're going to have smart dimension, which is essentially saying how long or how big something is going to be. These are essentially kind of like your quick start to any shapes that you want to make. So right here, you're going to have a line. If you hover over it, it shows you an example of how to use it. And you quick start to other shapes like a circle, rectangle, right? If I want to draw a rectangle from the corner, I want to draw a rectangle from the center, and different other options like that. Also, if you guys are confused about anything, please feel free to like interrupt me, because make this as interactive as possible. I don't want anyone to get lost. And if you don't know what anything is or why I'm doing things a certain way, you can always just interrupt me also and ask like why I'm doing it that way. So this is just where you draw all your shapes. And there's a lot of other tabs too that have a lot of different other options, but I don't really use those. So personally, I'm not comfortable with really teaching you guys what those are. A different tab I like to use also is the evaluate tab, where you could measure any dimensions of what you're making. And like, again, if you hover over any of the options, it will show you an example of like how to use it. So I use measure a lot also, and I believe it is mass properties once you start making your 3D objects. Okay, so these are your tabs for all the tools you're going to use. And then right here is the feature tree. So right here, you can see where the origin is and the planes that you could sketch on, and like other information such as your materials and history annotations. I don't really pay attention to those because I never had a need for those. Generally, you're going to see your features show up right here as you keep making it. So first thing to do is that from what I've noticed, a lot of people really like using the metric system when actually modeling, such as Chris, he uses the metric system. So we are going to be going with the metric system. So remember how I told you to stick with inches, pounds, and seconds? So if you want to do that, you can. If you feel like switching to the metric system, like millimeters, you can always go down right here at the bottom right, click on it, and then you could change what your units are. So for this workshop, we're going to go with millimeter, grams, and seconds because we're going to do everything in millimeters. Okay. Next, let's talk about basic controls. So if you scroll on your scroll wheel, that's how you zoom. Then if you hold down the scroll wheel, like press it, that's how you rotate. And you press spacebar, you could find the orientation you're looking for. So I'm going to make a quick 3D object, and I will show you what I mean. Okay, so I just made a block, essentially. So what I mean by basic controls is that if I scroll down, I'm going to zoom into it, right? And then you could kind of choose where to zoom into too. So if I want to zoom into bottom left right here, it will let me do that. Zoom out. If I want to zoom into right here, it'll let me do that. So the controls for that is nice. And if I hold down the scroll wheel, I could rotate, right? But let's say you get lost in the orientation and you kind of want to go back to just a defaulted generic view. You could always press spacebar, then click on what view you want to look at. So this would be your front view, this would be a side view, up view, and things like that. And if you want to go back to like isometric view, you just press Control-7. That brings you back to an isometric view. So if you get like lost in the sauce, basically, you can always just hit Control-7 or spacebar and change your orientation. So let's get started on making this thing. So we're going to actually make a sketch on the top plane first. So if you go under Sketch tab right here, what I like to do is I like to click on the plane in the feature tree first, and then I would click Sketch. So then it brings me into the sketch mode. Right here, you could see that this is darkened, asking me if I want to exit sketch. That means I'm in the sketch mode where I could start actually drawing lines, any shapes, and things like that. So what I am going to make first is I am going to use the rectangle feature, and I am going to make a center rectangle. And I'm going to place it at the origin. Okay. So just a little bit about all of this first. So when you're doing sketches on any kind of plane, you always want your sketch to be fully defined. And what that means is that the program knows exactly where it is in space and exactly how big everything is, right? So for example, you're going to see right here that it says it's underdefined, right? And it's generally always good practice to have your sketch to be fully defined, right? Because let's say you are making this in like industry, right? And then you're drawing your sketches, then it's not defined. It's possible that the sketch could like change its dimension when you're like clicking around. So that would be bad. And you also want the person looking at your 3D model or sketches to understand what's going on. So again, to fully define your sketch, you always want to know where it is in space and how big it is. So for example, for how big it is, anytime you draw anything and you want to space it out, you always want to smart dimension it, which is this button right here, right? So for example, for this line right here, there's two ways to smart dimension this. I can either grab it with just the line itself, say like this is 150 millimeters, right? Or I could smart dimension this line by grabbing these two sides. Saying that I want this from here to here to be 207 millimeters. So we'll just say this is 150. And then, so I'm not sure if you guys noticed, but you see how there's blue lines right here? Blue lines means that it is not defined yet. So these used to be blue, these vertical lines, but they're black now because the program knows where it is in space, and it also knows how wide it is from each other. And also for the sketch, you can tell something is like fully enclosed if it is dark in this space right here. So for example, I'm going to draw another rectangle. And then I'm going to draw something like this. Okay, so in comparison of all of these three, this one isn't filled in or shaded because it's not enclosed like these are. Right? There's an opening or a gap in it. And if you try to extrude this to like a 3D shape, it won't let you because there is an opening right here. It doesn't even know like what kind of shape it is. So, and it also, the program doesn't know where it is in space or how big it is because it still has blue lines. And for this one, no smart dimensions on it, right? So it doesn't know how big it is. It also doesn't know where it is in space either. So, any questions so far about like what I've just said? Like everyone gets what's happening with the sketches? Okay. So to make the general shape of that case that I just showed earlier, so remember to first smart dimension these, and then, so I want this to be actually before that. So you can see from the case that I was showing that it actually has its corners rounded off. So let's do that first. So from right here, we could use the sketch fillet feature to fillet each of the corners. So it's basically taking something sharp and making it round. So if you just click the 4 corners, and then let's make this fillet to be 5.08 millimeters. Okay. Then let's smart dimension this. So I'm gonna do this by clicking on the side. So for example, I want these 2 lines to be 117.76 millimeters. Yeah, what's up? Okay. Yeah. 0.6. And then anyways, okay. So is everyone on the same page? Is everyone on it? Who needs help to? All right. Justin's our helper. Everyone say hi, Justin. Hi, Justin.
Oh, but the kids are
It's none of the stuff you did have to require you to redesign.
I know.
Okay.
Oh, wait, no. This one's like, wait, oh, that's the game. 350%, I know. If I don't want it, I mean, it's every year.
Yeah, as long as they know where it has to be signed. This one's for Larry. If you have to make the diagonals,
You just make the rectangle.
oh, okay, okay. So this is the value. But I didn't want to find that. No, it's just like instead of, so you oh, okay. So if you use this right here.
For sure it's a top. They're on my top. Because they're gonna model this. Hey.
Yeah, like Christmas is like, oh, there we go. Now, sure, I started sort
Okay. Okay, so you said your other one you got. How does that happen? Yeah.
The tire is now not connected to the power train.
Yeah.
So,
Where did you raise it from? Like Enterprise or something? The first day you use it, oh, you don't Well, yeah, I was pushing hard for it. Oh my god. Was it skipping up? We didn't have like a friend that had a truck. That would be pretty just like, oh,
All right, let's continue on. I think everyone's on the same page, right? No one's got problems? Just making sure. All right. It's sad, or looks like everyone's on the same page. Alethea, is it good over there? Okay, so on to the next step. Okay. Okay, so after you've made this, you could go to the Features tab and then click Extrude. So basically what Extrude does is that it's actually like is making it into a 3D object, right? So you have your cross section, and now you're going to like make that cross section into an object. So for this, I'm going to extrude it 31.5 millimeters. And so for the extrude feature, you have different options of how you can extrude it, right? So you could, yes. You could double click the sketch in the feature tree. That lets you go back into it. And then once you could click on the features tab afterwards. Yes. Okay. Yeah. Is it good? Yeah. Okay. So there's different ways you could extrude this, right? You either blind extrude, where it just assumes where you want to extrude it, right? So you could click this arrow too, like, oh, I want to actually make it go up, or I actually want to extrude this downwards, right? There's other ones called up to vertex, up to surface. So I'm extruding it from one surface to the other. We're going to use that feature later. Extruding from the midplane. So there's just a bunch of different ways you can extrude this. There's more down here, but I will not be covering that because I barely use that, so I'm not comfortable teaching that. But we are going to be extruding this from the midplane, and we're going to be extruding it by 31.5 millimeters. So basically what this does is that it extrudes it symmetrically from the extrudes the 3D model symmetrically, right? So half of the shape is going to be made at the top, and then half of it is going to be made at the bottom of the sketch. So for example, if I click on the plane where I made the sketch, you can see that it's directly in the middle of my shape. Everyone did the extrude. Okay. Would be No, it will be half of that, up and down. The total will be 31.5. Yes. Okay. And then, oh yeah. So after we extruded it, we could see our feature right here, right? Where this says, this highlights what we did. So it highlights our extrude. So, and if you want to ever like go back into the sketch, you could always click this drop down right here and go back into the sketch to edit whatever dimension you want. Like, for example, what if I don't want the filleted corners anymore, right? I want to change this to actual rectangle instead. You can do that, and then once you click out of it, will update itself to be an actual rectangle. And if you ever make a mistake with how much you've extruded this, you can always go back into the feature itself and edit how much you're extruding it. So to do that, if you just click on it, there's going to be a pop-up where it says edit feature or edit sketch, right? So you could just do that if you've made a mistake. Okay. So, for sketches, it doesn't always have to be on like the given planes, like the front, top, or right. You can always do the sketches onto the object itself, as long as it's a flat surface. So for example, we're going to make a sketch right here. So I'm going to click on the top, then I'm going to go back to the sketch tab and make a sketch right here. Okay. Everyone's good with that? All right. So one of the tricks I've learned during one of my internships is to, over here at this line feature, it's always good to have construction lines, so it will help you figure out like how to space things. So if I click center line over here, it shows me my options again of like what I can do with it, right? I can make a midpoint, make it be a midpoint line, so it's just symmetric. Like for example, if I click right here, it's symmetric from left to right. It will, the line on the left will be equal to the distance to the line on the right. So for example, if I made this 10, it would be 5 on the left and 5 on the right. So a good trick that I learned is that when you make center lines and you see right here for construction, what that means that it's literally there to just help you space things out, right? So if I were to click like extrude for my shape while it's attached to a construction line, the construction line won't show up in the extrude. Construction line is just there to help you get everything spaced out and where you want it to be. So a good trick I learned was, a good practice is to always just have infinite construction lines at the origin so that it will help you space things out. So click here, the center line, then make sure that for construction is checked, infinite, and I'm going to make 2 of them. I'm going to make one that's going to go vertically straight, and then one that's going to be completely horizontal. So you see here, as I'm like turning it, when it's about to be vertical, it's going to tell you it is vertical because it snaps into place, right? And under the pencil, you can see that it has a yellow vertical line, meaning that there's going to be a constraint on it, right? So what a constraint means is that you're forcing it to have a relationship. As in, for example, a vertical constraint will forever make that line vertical. And same thing with horizontal, right? So I'm going to draw another one here at the origin. So you can see it snap, and this one will forever be vertical. So another good practice, or another thing that you can do to make less work on yourself, is that if you know your sketch is going to be symmetric before even making it, you can always think about where it's symmetric about, right? So you can draw part of it, and then you just start mirroring it across the like axes or the lines, which is why I have my infinite construction line right here. Because I'm going to be making a cut onto the cake on the top right here. I know that it's going to be completely symmetric vertically. And another thing I want to address is that, so before that, click on the line and then I'm going to attach one point to this construction line here. And then I'm just going to start randomly making lines. Okay, so you don't have to have everything exact all the way, right? And I know that my sketch is going to be completely symmetric, left and right, and up and down. I apologize, it's not the right vocabulary, but you don't have to have everything already set, right? You could always play with the constraints so that it could be, if you mess up, you will have a way to fix it by placing constraints. So for example, I want this line to actually be horizontal. And how would I do that, right? I could click on the line, and in here, the tree, it goes to my line properties, right? And right here shows add relations. I could either make it horizontal, make it completely vertical, or fix it so that it's just stationary right there. And I want this line to be horizontal, right? So I'll just click horizontal. Now that whenever I drag this line now, it will always only ever be horizontal. And same thing with this line too. I want this line to be vertical, so I'll click vertical constraint, and this line will only ever be vertical now. Okay, and I also want to attach this point to right here, right? Because I accidentally I didn't click on the line when I was drawing this line. I didn't click the infinite construction line. I did not attach the point, the infinite construction line when I was doing this, right? So how would I do that? You can hold control, click on the point, and then click on the line and say that you want it to be coincident. Coincident meaning that I want to attach these two things together. So if I click coincident, you're going to see that this point will forever be attached to that line. Okay. So did everyone get that? Like you just need this general shape, regardless of whether you followed me on like drawing random lines or you have this. So is everyone good, or does anyone need help? Okay. Yes. I need to speed up. Okay, yeah, it's good. Okay, so for those of you who have used SolidWorks, this is actually a pretty neat trick that I learned. When I go into my smart dimension, so for example, I'm gonna want my sketch to be like, let's say 100 millimeters from right here to right here, right? So when you're making a sketch, right, like just part of it before you start mirroring everything, you don't have to think in like quarters or halves, like, oh, how much is this gonna be? Like maybe from here to here is like 50, right? So for those of you who actually have used SolidWorks, there's a neat trick where you smart dimension from here, and then you actually click on the construction line, drag it over. It will show you a like length or like the mirror, if that makes sense, right? So for example, it says 108.49 right there. if I were to mirror this across that axis right now, the length between the point on the left and the mirror is going to be 108.49. So let's do that, or let's not do that yet. All right. Actually, yeah, let's do that right now. Okay, so again, so one more time, smart dimension. I'm going to click from this line, click the infinite construction line, pull it over to see the full length. And then I'm going to make this 106.68 millimeters. So click check. All right, everyone got that? Yes, yes. Okay. I'm going to make this distance from here to here to be 43.3 millimeters. And then I'm going to make from the top to this line to be 55.8. And then I'm going to make this line from here to, so smart dimension from this line, pull over, oops, sorry, I already did that. Oh, all right, smart dimension from this line to this infinite construction line, pull it over, oh, that's not it either. Oh, I already did this, sorry. Okay. All right, this time actually. Smart dimension this line to this line, the vertical infinite construction line, and I'm gonna make that 94.1. And I'm gonna make that 94.1 millimeters. Okay, so is everyone over there for now, or who needs help? Everyone good? Anyone need help?
No, he had to well, I think he's trying to get the overall dimensions and then across the axis. So you select the line, you select the axis, and you just drag the cursor up, and it should double, instant double. So it's just like normal dimensioning. You select the line of dimension, and then you select axis.
What are you doing now?
I'm trying to increase the size of the text.
Oh,
God, like where that is.
I mean,
So we want this distance here. Okay. And then so we need to color the thing. Yeah, okay. We're gonna do just over here. That's gonna be 94. Okay. No, just use the games. Ryan. There you go. Oh, shut up. That's also the next homework. Okay. No, I'm not gonna hear this, but every single time I select this line, it's not letting me.
What are you doing?
Well,
he's trying to increase the size of the text.
There we go. It's a little bit bigger. Should I make it bigger? I'll make it bigger.
We're having a Ross talk about a poet.
Oh no, get me out.
I like Ross either. I don't know how I like Ross.
Okay, I didn't work with Ross, but during UAV research, there was a bunch of people near me who did a lot of Ross, and they hated it. So
It simplifies everything.
make it 24.
Click on the extension.
What?
Actually, exit the sketch first. I just need to see the demo. And click on the sketch. 117.6.
I don't know exactly.
Oh, perfect. Oh, yeah, no, it's so we can jump around. If you put that on the gold piece, oh, sure, you have that. Oh, that's no, it's a good get for this person. Applications all works.
Why is it exactly the same size as what I wanted? Why did I look up a part that's like exactly the size of it? Like, how is it? Did it adjust it?
No. No low stays in the retail. Fast enough, so more it's complementary. Sí, 3 años de la clase de español. Tú hiciste la clase de Spanish.
That was crazy.
Yeah.
Wait, so what are you taking? We did it for the C1 or C2. You take it again? You know what's easier? You should be taking history of Spanish. It's the one. The online one?
11:10. Yeah. Because I have, my teacher is Amelia Lombard.
Yeah. That's so easy, that class. I dropped Spanish once to take that one. It was fully asynchronous.
Yeah. I love asynchronous.
This is the best.
So, like, it literally has me miss the work week. The whole week.
No, the problem is she doesn't let me go too far ahead, or else she'll like give like cut off or something like that.
She'll lock you out of the room.
So I just do the maximum 2 ahead, and I just keep saying 2 ahead.
That's right. Is that what you want? Oh.
I forgot, I did this process by I realize that now, but that's more and that makes it a lot worse. I think it's probably more like the use of it. You said you like 250 or something? Wait, what did you say to was 250? You said something was 250. That's oh, the library place. That's compared to your yeah, that's the best. Do you just use regular filter or what do you use? You use like the filament that hammer. Yeah, like, yeah. You use that? That's why it's here. Do you usually do like side projects that you use for stuff?
Don't tell me it's just collecting dust cans. Don't tell me. Don't tell me.
It's still in the box. I took it out. So I took it out.
It's the potential. You're trying to set the precedent when you before you.
Alright, so everyone good.
Okay, so this thing ends at 8, so I don't think we're gonna finish, but hopefully I will get to the important parts I am trying to emphasize. Okay, so that's why. Anyways, all right, so okay, so we're gonna notice is that everything is black, right? That means everything is defined as in it knows where it is in space and how big everything is, right? So I know that sketch right there, just that corner, horizontal. So instead of like drawing like the lines all over again, right, and then dimensioning those again, you just mirror it, right? So if you click on mirror entities right here, on this tree, it shows you the entities to mirror, as in what am I going to mirror and where I'm going to mirror it about, right? So for example, I'm going to click this first. I'm going to click this line, all these lines right here. So you should be mirroring 4 lines. If you make a mistake, it's okay. Just right click it, then click delete. So it kind of just unselects it, if that makes sense. But yeah, everyone's good? The 4 lines? All right, and I am going to mirror this about the vertical axis. Okay, so what you're going to see here is that you know how we had the smart dimensions earlier, right? As I said that I wanted from right here to be 100. You're going to notice that the smart dimension actually reaches from this line to this line, right? So you don't ever have to think in like halves or quarters. You just say, oh, I'm thinking that this probably is going to be like 100 something wide, right? And you could just mirror it later after you figure out the dimension, or you could mirror it first and then dimension it later. Okay, so then you're going to do the same thing. Click mirror entities again. I'm going to click all the lines on the top half. So like right here, you see I made a mistake. I clicked the point. I don't want that. Just delete. Deleting it unselects it. I'm going to click this line, this line, this line, and this line. Okay. So you should have 8 lines selected and then mirror about the horizontal axis. Then click check. All right. So, okay. So now that I have the shape I want, again, you always want to check if your sketch is fully defined. So you can tell it's fully defined generally by right here on the bottom right, if it says it is fully defined. Again, fully defined meaning it knows where it is in space, like it's attached to something, and it knows how big everything is, right? If I start trying to drag this, I can't because it already knows how big everything is, right? And it knows where it is. For example, if I were to have deleted this dimension, right? You see that there's blue lines. If you ever can't figure out why your sketch is underdefined, you can always just start grabbing on things and then start pulling it, right? So I'm pulling on this and I realize like, oh, like, does it know how tall this thing is, right? So I can just smart dimension it and then it will fix it. So just Control Z. Okay. So also another example, let's say you just like exit your sketch, right? But then you want to use that sketch for a feature. You could always just go to the features tab. I want to use that sketch to make a cut, right? So I'm gonna say I want extruded cut, and I'm gonna click the sketch that I want to use to make the cut. So you could do that too. So you can either be inside your sketch, then do the feature, or if you're outside your sketch, you could click the feature first, and then the sketch that you want to make that feature. So for this, I am going to make it a blind cut. So I'm rotating it, right? Generally, SolidWorks can guess what you want to do, but sometimes if it's in the wrong direction, you could edit it, right? So for example, it knows that I want to cut through objects, so it assume that it's pointing downwards, which is good, right? But what if it was pointing like in a different direction, like up, right? You can always click this direction to change the direction it's cutting. And then I'm gonna make this a 5mm cut. Okay, did everyone get that? Or does anyone need help? Yes?
What? Bro. Why do you need these slicing programs? That's crazy. Oh, okay, there you go.
First sounds better, you know, like no, it's okay. So you don't like this United States where you get like sound bags, yeah, because of that plastic box. This is just like a solid version. Take it out of the thing and put the bags in. Yeah. Am I gonna look at the inputs? Okay, whatever it takes to use. It's not a powerful gear, but it's got a big screen.
That's
So we started our own.
I mean, yeah, a little. Take the bag out and then throw the plastic container away and put the bag in. You break it like a few more too, so it's like more You know what? Okay, you know if I got this center here? You know what? I went to read for there.
Okay, so alright. Since there's only like about 15 minutes left of the workshop, we're not gonna get through everything of like how to where is the case? So we're not gonna get through to how to actually fully make this. But the things I want to emphasize on good practice for 3D modeling is that one of them was having your sketch fully defined, right? We just got that. Knowing how to use the basic tools, we got that kind of. And I think another thing I want to emphasize is being able to make what you want with the least features as possible. So what I'm trying to say by that is, for example, if I were to make a really simple cup, right? How would I do that? I would make a circle, then make it an extrude, right? And then I'll just draw another smaller circle, then I would cut through it, right? And that would get me my cup, right? But it's possible that if I had a cross section of a cup, I could actually just rotate that instead, and that will get me that instead of doing two features. So I am going to go off course. So I will hide this. Okay, so you don't have to follow along for this. I'm just going to show you what I mean. So for example, I'm on my sketch. Where is my
Here. It's over here. I don't know. Inside the region. Like yeah, like here. Sure. All right. I don't know how we can handle that for soft. I feel like no. Okay, well, this isn't gonna be in the library. That's just reality. You don't know how. That's great. You got a friend?
Okay, so before this ends, going off course, the last thing I want to emphasize is being able to make something that you intend with the least amount of features as possible. So for example, for the cup, you can see how, like just from the preview, that you can make this cup by making a big circle, extruding it, right? And making a smaller circle, and then cutting it, right? But for example, for this one, you knew what the cross section of your cup is going to be like, just like this, right? You could just rotate it about an axis and you'll get your cup, right? So instead of actually using two features, an extrude and then a cut, I'm using just one single feature to actually make this cut, right? And I want to emphasize that because when I was actually working, that was what was told to me. As for example, you want, or whoever looks at your 3D model, like your sketches, your dimensions, or whatever you do, you want it to be as like understandable as possible. And being able to make something with the least features as possible is part of making your model understandable. Right? So for example, if I just click check right here, you can see that it's going to be like the cup I want. Right? And if I ever want to edit this cup to make it wider or any like smaller, I could just go back into the sketch and I will be able to edit the like what this is. Okay, so basically, sorry that we couldn't get through all of this. There was a lot of technical difficulties, but main takeaways is hopefully you know how to use like all the basic tools. At the end of this, we're probably gonna do ping in the Discord, showing like what I used to learn it also when I was taking my class for Solidworks. So you could use the mirror feature to always like make less work for you. And last takeaway is to use as least features as possible to do what you need, right? And if you can, like try to make things symmetric so that you can always just mirror things together so it creates less work for you, right? Like if I did like 30 different extrudes and cuts, right? But I know it's going to be completely symmetric on the left to the right side. I could just mirror all those features for the cuts from the left to the right. And that is about it for me. But if anyone has any questions, I can answer them. Yes. Oh, yeah, no worries. Alright. WR. I did the rotate skin.
I love the rotate skin. Can you speak right going to traffic and all?
How long was that day? How long was that day? 120 miles. What is it? Bro, there was.
Apparently they have like yeah.
Like
I was talking
like
in terms of like
data management.
you know like any communication is like apparently it's not very good.
Really? There's a whole comms. Yes.
Oh.
No, please.
Bro, change it. Sorry, that's where you're that's crazy. I swear. You guys are.
Because no one's helping me. Yeah, it does. So you
Is that your Wi-Fi? Yeah.
This is what was class, right?
That was like an example piece. You know what? I had to. So next week isn't allowed, is it? Next week is PCB design. Well, second analysis, right?
Yeah, this is
But circuit analysis is like not.
Oh, that's not right there.
I think it's like a separate topic. I don't know. I don't think I know. Me neither.
Really?
Today I learned about capacitors.
Is work done?